Please pause the video at this time and complete the warm-up. The answers to the warm-up are as follows. Notice that in this first question, we want to use the product property and rewrite this as 3 separate logs. You might have missed, but 9 is actually 3 squared. So technically, you can rewrite that as 2 log base 2, 3, or you could have even thought of this as 3 times 3. So you could have said log base 2, 3 plus log base 2, 3. And that is equivalent to 2 log base 2 3s. Now, the other 2 logs, you have to just make sure that they are fully simplified. So for the second log, you can bring that 3 to the front. And for that last one, since it has a y, there's no evaluating we can do. For the second problem, do not forget that if you have a root or a radical of any type, you want to make sure that you rewrite it with that rational exponent. And then really think, this is just the product of 3 and a to the 1/3. So products can be rewritten as the sum of each part of that product with the same base. Do not forget to move the 1/3 to the front at the end. And then finally, this last one is the trickiest on here. Right away, you have to take care of that quotient because the quotient affects the 6, the x squared, and the y. Now, after I took care of the quotient, I noticed that I had a product here with x squared and y to the 4th. But you need to make sure that when you separate that into 2 logs, because there is this minus sign in the front of that log, you need to make sure you distribute the negative to each log you create. Keep in mind, if you were to work backwards, anything that follows a minus sign would go in the denominator. So you want to make sure that both of the logs that you expand this into have a negative in front. That's very important. Then from there, you can move the powers to the front. If this idea doesn't make sense to you completely, don't worry. We will address it more today. Now, moving on to today's notes. Today, we're going to talk about how you can work backwards and take the properties and now use them to condense log expressions. In other words, you're going to start with something that looks like this, and then you're going to work backwards to get to something that looks just like 1 log. This is very important for solving, and this is something we'll address later on. So let's talk about the properties in reverse. Now you're going to see the problem, and it'll be an expanded form, and to condense it, we're just going to work backwards. Think if you have a plus sign in between the logs. Remember that means that product property. So you can rewrite this as 1 log with a base of b, and then the product being a times c. Now, for the next part of this, we have the quotient property. And remember, when expanded, it looks like what's given here, with a minus sign in between the 2 logs. But when condensed, remember that a minus sign means quotient of a over c. And again, parentheses are fine if you want to put parentheses there, you don't have to. And then finally, the power property, when expanded, looks like this. But when condensed, remember we bring that c back, and that becomes the power on the argument. So then that right there would be your answer as a condensed log. So let's look at how this is done. For the first problem on the notes, what you're going to do is you are going to focus on what we are seeing in between the logs. If we are condensing, we're going to condense this into just 1 log. So you need to think about if you have a 10 and a 4 and there is a plus sign, you would make this the product of 10 times 4 or 40. So we're going to multiply that 10 times the 4 and we're getting that 40. Now I'm going to rewrite minus log 5, but we have to keep going because now we have a minus sign in between the 2 logs. So minus means quotient. So now you're going to take these 2 logs and condense it into 1, making the quotient of 40 and 5, which in other words is log 8. And that is your final answer. Now, you should always try to evaluate if possible, but remember logs normally have a base of 10, and 10 to some power is not equal to 8. There's not going to be a nice number there. There is going to be a number, it's just not nice, so we can leave it just like that. Now, moving on to the next question, you're going to see that this question, we have a plus sign in between the two logs. So I'm thinking product, but before I can take care of the product, I have to move this power back. You may say, why? Well, going back up to our warm up, remember that the last thing we took care of were moving these powers to the front. When you condense, you're working backwards. So that's actually the first thing you want to do. So you're going to take this power and you're going to move it back. Daddy-o, 3 hops this time. No, I know that's not how the song goes, but I always think of that when I do logs. So you're going to bring that back and you're going to make that a to the 1/2 power. Now, from here, I know that a to the 1/2 power is really the square root of a. And then I can look at that power, that operation in between, and I can rewrite this as log, and then that product of 6 times the square root of a. And again, that could all be in parentheses if you want, but that is your entire argument. So why did I do that? Because we have a plus sign, so I'm going to make it the product of those two arguments. And then final set problem in this set, we are looking at the power of 2. We can bring that back. The power of 4, we can bring that back. So we get log base 3 of 49. Why 49? Because this became 7 squared, which is 49, not 7 times 2. It's the power on that base, minus log base 3 of x to the 4th. Now, after you take care of the powers, you then have to look at the pluses and minuses. I noticed that for this problem, I have a minus, which means quotient. So I'm going to rewrite this as log base 3 of 49 over x to the 4th, and that is my final answer for this question. Now, we're going to use these ideas to evaluate expressions. It's basically exactly what you did, but at the end, you're going to be able to use that circle of life in order to actually get a numeric answer. So what do I mean by that? Well, for this one right here, we are going to start by looking at the operation in between. I see that it's plus, so I'm thinking product, which means I'm going to take that 4 times the 9, or in other words, 36. Now, if you want to evaluate, you're thinking circle of life. 6 to what power is 36? So you can do that 6 to the x power equals 36. Either think about it and just get that x is equal to 2, because 6 squared is 36, or get that same base on each side, and then you can get that that answer needs to be 2. Same thing with this next problem. The difference with this next problem, though, is now we have a minus sign, so let's think quotient. We're going to take this 35 and divide it by 7. And remember, 35 divided by 7 is 5. And then to evaluate, think 5 to what power is 5? You can either write it out like this, or just think about it. We get a value of 1, because notice that x would have to equal 1 in order to make this work. Moving on to the next question. This one does have a power in front, so bring it back, Daddy-o. And you get 6 squared minus log base 3 of 4. 6 squared is 36. Once you take care of the power, we can then look at the operation in between. Because it's subtraction, we are going to make a quotient of 36 and 4, which is equivalent to 9. So to evaluate this, think 3 to what power is equal to 9? If you don't know it right away, get the same base, and then that is going to be what that power is equal to. So x is going to equal 2. 3 squared is 9. Final question in this set. We're going to bring back that 1/2. So we get log base 3 of 9 to the 1/2 power minus log base 3 of 27. Do not forget 9 to the 1/2 power is really just the square root of 9. Well, we know that the square root of 9 is 3. Now, this is a cool question because from here you can actually get away with solving this without actually using the properties of logs from here forward. So let me show you the two different ways you can do this. Way one, you might right away see log base 3 of 3, 3 to what power is 3, that's 1, minus log base 3 of 27, well, 3 to what power is 27, that's 3. You can get this answer of -2. The second way, though, is using the properties. You see this minus sign in between the logs. You can rewrite this as log base 3 of 3 over 20. Ooh, that's not a 3. Try again. 3 over 27. When reduced, that's really 1 over 9. So you're thinking 3 to what power equals 1/9? Well, I know 3 squared is 9, but I want the reciprocal of that, so I can get -2. Or again, remember, you can rewrite the 1/9 as 3 to the -2nd power and get that answer of -2. So either way, you'd get the right answer on that. So if you could please pause the video, do the you try A and B, and then come back and check your answers. Here are the answers for the you try. For the first one, you made a quotient, 2 to what power is 8, that should be 3. And then for the second one, you also made a quotient, 4 to what power is 1 over 16.